Hello, this is Virgil, Labrador, Editor-in-Chief of Satellite Markets and Research, and we're here at the Africacom 2018 in Cape Town, South Africa, with Eran Shapiro. He's the Vice President for Business and Technology Ventures for satellite operator Amos Spacecom, and here to talk about Amos Spacecom's presence in the African market and other regions is Eran. So Eran, welcome to this videocast.
Thank you, Virgil. Nice to be with you here again.
Yeah. Eran, just start off with maybe giving an overview. What services do you provide for the African market?
Sure. We currently have two satellites providing service over Africa. Mm-hmm. One is Amos 4, which is a dual KU-KA satellite. We provide KU services over Eastern Africa for some large customers. And we also have Amos 7, which is a KU-only satellite. This one is at another orbital position for West, which is our hotspot, both for Europe and Middle East, and also for some African services. And that satellite has a very strong KU beam covering the southern part of Africa. And we have some new and exciting customers boarding that satellite in the last few months. And we also have Amos 17, which is going to be launched by mid next year to a third orbital position from which we will be serving Africa. This is 17 East. This is an African-centric type of satellite, and it's a tri-band KU, KA, and C-band, which will be providing much more capabilities and capacity compared to Amos 4 and Amos 7.
It's a high-throughput satellite, right?
This is a mixed type of satellite. We have on it three types of payloads. We have a high throughput steerable KA beams. We have fixed KU beams, which are focusing more on the broadcasting business.
Right.
And we have something new and innovative. We are the first in the world to offer Africa. It's a true high-throughput satellite in C-band.
Oh, high HTS in C-band.
That is correct. Usually when people are thinking HTS, they're usually thinking KA, consumer broadband, SMBs. Sometimes they also think about KU.
Right.
But in our case, we have full coverage over all of Sub-Sahara with small spot beams. This enables us to answer some of the customer requirement we've been gathering from the African continent for the last few years. First is, we have already some business critical type of applications like cellular backhaul, like capabilities and capacities for the enterprise and the government markets. These are customers who are heavily relying on C-band, and they want to enjoy also the high throughput and the higher efficiency of an HTS versus traditional satellites. So we set with those type of customers, and we planned the payload of the C-band HTS on Amos 17 to answer their specific requirements. So example of the requirements is simplicity in the on the hub side. So if you have got a country which is covered by multiple beams, this means that your cost at the hub and the operational side as well as the capex side are higher. Right. So one requirement that we received from the market is to ensure that each country is covered by a single beam.
Right.
Other requirements were if you want to support the expansion of connectivity within Africa in an economical and reliable manner, we don't want to invest too much on the remote sites because then expanding the cellular network or Wi-Fi based networks to very remote locations is going to be too expensive.
Right.
So first, the initial investment on those remote sites should be as low as possible. And second, also the operational aspect of it should be as low as possible as well. An example, if you want to go to remote sites which are off-grid,
right,
and you need electricity one way or another. So
Right.
one way is to use generators, and that works fine. The problem is the initial cost is high, and you should fuel it all the time, which is a nightmare when you go really to rural Africa locations. If you want to go to something which is solar-based only with batteries, there is a limitation to how much power you can put there without increasing your initial cost too much.
Right.
So another aspect of this unique C-band HTS is that we have created the beams to be very high on the G-on-T. Well, basically, our edge of coverage for G-on-T is higher than the peak of all traditional C-band beams over Africa. What we allow with that is first, of course, to use smaller antennas on those remote sites,
Right.
but also the amount of power needed for the return channel, for the block-up converter, the back to use, is much lower. As a comparison, if we are using a 2 megabits per second return channel from a remote site,
Right.
then with traditional satellites, in order to be able to generate it, you need more or less to consume 8 to 10 watt of power.
Right.
Without satellite, we can do that with less than 1 watt.
Right.
So moving now in those remote sites to much lower and much efficient power regime is now possible, which was not possible in the earlier days.
Anything else we can expect from Spacecom?
Sure, quite a few things. The first one is we are currently on the process of building our Amos 8, which is going to join 4 West, our prime orbital locations. And we have, in additional, we are currently exploring how to develop 2 of our other orbital locations. And you know, we as a small, let's say a rather small satellite operator, we have to be ahead of the curve. And you may recall that at the time we were discussing the uniqueness and the innovationness of our Amos 6 Ka payload at the time, as well as what we discussed right now about our Amos 17 HTS. And in the same manner, we expect to have something unique in terms of both value delivered and capabilities which are going to be new to the market with these 2 additional satellites to be purchased after Amos 8. So there is something to look forward for.
Right, right. Well, thank you very much, Eran.
Thank you, Virgil.
And for all the news and information on the global satellite industry, you always have Satellite Markets and Research at www.satellitemarkets.com.